Two of the most powerful observatories ever built by human beings just confirmed they were staring at the exact same object, moving through our solar system on a path that no telescope on Earth had ever tracked before it arrived. And the story of how that confirmation actually came together is stranger and far more carefully documented than almost anyone realizes. One of those instruments is the James Webb Space Telescope, parked 1 million miles from Earth, reading the chemical fingerprint of starlight one wavelength at a time. The other is the Vera C. Rubin Observatory, a brand new facility in the mountains of Chile that had not even officially opened for business when it captured its first images of this thing weeks before any human being on the planet knew the object existed at all. When scientists lined up the data from both instruments side by side, what they found was not something manufactured, not a message, not anything built by another civilization, but it was genuinely one of the strangest chemical samples ever pulled from the depths of the galaxy, and it is still raising questions that nobody has fully answered. Before we get into exactly what these two observatories found, I want to be upfront about something, because there is a version of this story spreading online right now that claims this discovery is being hidden from you, tied to old prophecies and secret memos and an alien arrival supposedly scheduled for later this year. None of that is real, and by the end of this video you will understand exactly why, because the actual documented science here is remarkable enough, without any of that added on top of it. Stay with me, because this is the real story of what Webb and Rubin actually confirmed, told the way the scientists who did the work would tell it themselves. If deep dives like this one, built entirely on published research, rather than manufactured panic, are what you come here for, go ahead and subscribe now, because this is exactly the kind of story worth getting right. To understand how two completely different observatories ended up staring at the same target, you first need to understand what that target actually is, and how it was found in the first place, because the discovery itself is almost as strange and almost as improbable as anything that came after it. On July 1st, 2025, a modest survey telescope stationed in Rio Hurtado, Chile, called ATLAS, short for the Asteroid Terrestrial Impact Last Alert System, caught a faint point of light moving in a way that did not match anything in its catalog. ATLAS exists to scan the sky night after night looking for anything that might be heading toward Earth, and what it found that particular night turned out to be something far rarer than a threat. Within days, astronomers around the world confirmed what the object's orbit was telling them. It was not looping around the sun the way every native comet and asteroid in our solar system does. It was moving on a hyperbolic path, an extreme, wide-open trajectory that only makes sense if something arrived from outside the sun's gravity entirely and is simply passing through on its way to somewhere else. It was given the formal designation 3I Atlas. The letter I marks it as Interstellar, and the number 3 tells you it was only the third such object ever confirmed, following a strange, elongated visitor called Oumuamua in 2017, and a more ordinary-looking comet named Borisov in 2019, two prior visitors that had already taught astronomers just how differently these objects can behave once they arrive. At the moment of discovery, 3I Atlas was already moving at roughly 137,000 miles per hour, and it was still well outside the orbit of Jupiter, a speed and distance combination that told researchers immediately this object had been accelerated by something far beyond our own solar system long before it ever crossed paths with the sun. Here is where the story takes its first genuinely surprising turn, and it involves the Vera C. Rubin Observatory, a facility that was not even supposed to be part of this story yet. Rubin sits on a mountaintop called Cerro Pachon in Chile, and it houses the largest digital camera ever built for ground-based astronomy. A 3.2 gigapixel instrument attached to an 8.4 meter telescope, specifically engineered to photograph enormous swaths of the night sky repeatedly over and over, building a moving record of everything that changes from one night to the next. Its full survey, once running at capacity, is designed to image the entire visible southern sky roughly every few nights, a scale of coverage that no previous ground-based telescope has ever managed to sustain. At the time 3I Atlas was officially discovered, Rubin was still in its commissioning phase, a period of testing and calibration before the observatory formally began its main survey, meaning the telescope was not even supposed to be producing usable science data yet. But because Rubin had already been quietly imaging patches of sky during that testing period, researchers went back through the archive after the comet's discovery and found something remarkable. Rubin had already captured the object, completely by accident, during routine commissioning activities, in observations stretching from 10 days before its official discovery all the way up through several days afterward. Astronomers led by researcher Colin Orion Chandler recovered 49 separate images of the object hidden inside that early data, 37 of which were detailed enough to be used in a formal scientific study. In other words, before any human being on Earth knew 3I Atlas existed, one of the most powerful telescopes ever built had already photographed it in detail, sitting quietly in an archive, waiting to be noticed by anyone who thought to go looking. Those early Rubin images turned out to be more than just a curiosity. Because Rubin's optics and its enormous camera are so precise, the images gave astronomers one of their first solid physical measurements of the object, well before most other telescopes had a usable look at it. Based on that early data, researchers estimated the comet's solid nucleus to have a radius of approximately 5.6 kilometers, with an uncertainty of about 700 meters, making it substantially larger than either of the two interstellar visitors that had been confirmed before it. The images also revealed something about the shape of the material streaming off the comet that puzzled the team at first. Instead of a tail pointing away from the sun, the way you would expect from ordinary solar wind pressure, the early images showed material appearing to stretch toward the sun, a configuration that had been seen before in a handful of other comets, but which still required careful modeling to explain. The team ultimately concluded that if dust were being shed roughly evenly in all directions from the nucleus, the geometry of the comet's position relative to Earth and the sun at that particular moment could produce exactly that sunward-looking appearance, without requiring anything unusual about the physics involved. They also checked for another possible explanation, active gas jets pushing material in that direction, but spectroscopic observations taken on July 3, 2025, detected no gas emissions from the object at that early stage, which supported the simpler explanation involving dust rather than active jetting. It is worth pausing on that detail, because it is a perfect example of how real scientific investigation actually works. A strange-looking image does not get published as evidence of something exotic. It gets tested against multiple explanations, and the team reports the one the data actually supports, even when a stranger, more dramatic answer might have made for a more shareable headline online. That is the first genuine confirmation this story hinges on. Two completely different instruments, one designed to survey the whole sky repeatedly, and one designed to stare at a single target with extraordinary spectral precision, both independently capturing hard data on the exact same object, arriving at compatible physical descriptions of what it actually is. But the story of what these two observatories confirmed did not stop with a size estimate and a tail direction. Once 3I Atlas moved close enough to the sun to begin actively releasing gas from its surface, the James Webb Space Telescope turned its full suite of infrared instruments toward it. And what it found over the following months turned this object from an interesting orbital anomaly into one of the most chemically significant discoveries in the short history of interstellar object research. In a solar system comet, you would expect water vapor to dominate the gas streaming off the nucleus as it warms, since water ice is the most common frozen material comets typically carry, the way it has been carried in essentially every comet astronomers have measured up close within our own neighborhood. That is not what Webb found. Working alongside NASA's newer Sphere-X mission, Webb's instruments determined that the coma surrounding 3I Atlas was overwhelmingly made of carbon dioxide, accounting for roughly 95% of the detected gas, with water making up only a small fraction of the total. Webb also picked up tiny water ice particles and carbon monoxide gas mixed into that coma, revealing a genuinely layered, complicated mix of frozen materials all warming and releasing together as the comet approached the sun. A carbon dioxide-dominated coma at this kind of distance from the sun is unusual, and it suggests the object originally formed somewhere extremely cold, far colder than the region where our own solar system's comets condensed, in an environment where carbon dioxide ice could survive and accumulate more easily than water ice ever could. Researchers who authored the early paper on this detection described it as direct evidence that 3I Atlas came from a formation environment fundamentally different from anything in our own solar neighborhood, a place with different temperatures, different pressures, and quite possibly an entirely different chemical starting inventory than the disk of gas and dust that eventually built our own planets. Then, in June of this year, Webb made a discovery that surprised even the researchers who had been tracking this comet closely since its discovery. Analyzing new data collected by Webb's mid-infrared instrument, scientists confirmed the presence of methane hidden beneath the comet's outer surface, the first time this particular molecule had ever been directly detected on an interstellar visitor. Methane is highly volatile, meaning it converts from solid ice into gas very easily once even a small amount of warming reaches it, which makes its delayed appearance in the data genuinely informative. The signal showed up in mid and late December of last year, roughly 2 months after the comet's closest approach to the sun, suggesting the methane had been buried below the surface, shielded from sunlight, until deeper layers of the nucleus were finally exposed and warmed enough to release it. What caught researchers off guard was not simply that methane was present, but how much of it there was relative to water, a proportion noticeably different from what is typically measured in comets that formed inside our own solar system. That imbalance suggests 3I Atlas did not just originate somewhere else. It formed under a genuinely different set of physical rules, in an environment where the balance between these frozen ingredients played out differently than it did in the material that eventually became our own planets. If you are finding this explanation clearer and considerably more grounded than the versions currently circulating online, take a moment to hit, like on this video right now, because it genuinely helps careful, sourced science reach more people instead of letting exaggerated claims dominate the conversation entirely on their own. There is one more chemical discovery that deserves its own careful explanation, because it might be the single strangest thing anyone has measured about this object so far. In March of this year, a team led by astronomer Nathan Roth at American University used the Atacama Large Millimeter Array in Chile, a separate and highly specialized radio observatory built to detect the faint submillimeter signatures of specific molecules, to study the comet's coma in yet more detail. Using the array's more compact set of dishes across multiple observing dates in late 2025, the team focused specifically on two molecules, methanol, essentially a simple form of alcohol, and hydrogen cyanide, a nitrogen-bearing organic molecule commonly found in comets of all kinds. What they found was that 3I Atlas is extraordinarily rich in methanol, measured relative to that hydrogen cyanide baseline. Across two separate observing dates, the team measured methanol to hydrogen cyanide ratios of roughly 70 and 120. Numbers that place this comet among the most methanol-rich objects ever studied, solar system comets included, surpassed only by one unusually chemically extreme solar system comet discovered years earlier. Roth described the finding by saying that observing this comet is essentially like taking a chemical fingerprint from an entirely different solar system, and that the details reveal a composition unlike almost anything typically seen in comets closer to home. That combination of findings, an atmosphere dominated by carbon dioxide rather than water, a surprising and delayed release of buried methane, and now an extraordinary abundance of methanol relative to other common cometary molecules, paints a consistent picture across three completely independent instruments and three completely independent research teams, each working with its own equipment, its own funding, and its own set of assumptions going in. This is not a single strange reading from one telescope that could be written off as noise or instrument error. It is a repeated, cross-confirmed chemical signature gathered by Webb, by SphereX, and by ALMA, and it all points toward the same underlying conclusion that 3I Atlas formed somewhere fundamentally colder and chemically different from anything that built our own corner of the galaxy. That brings us to the question of exactly how old this object actually is, because the answer turned out to be even more extreme than its chemistry alone would suggest, and it is where the story genuinely stops feeling like ordinary astronomy and starts feeling like a message from a much deeper stretch of cosmic history. In a separate study published on June 22nd of this year in the prestigious journal Nature, a team led by Martin Cordner at NASA's Goddard Space Flight Center used Webb's instruments to measure the ratio of two forms of carbon in the gas streaming off the comet, ordinary carbon-12 and the heavier isotope carbon-13. Almost all the carbon in our galaxy gets produced inside stars considerably more massive than our own sun, and the balance between these two isotopes shifts gradually over enormous stretches of cosmic time as generations of stars are born, live, and eventually die, slowly enriching the surrounding galaxy with new material. Cordner's team found a carbon isotope ratio containing far less carbon-13 than anything ever measured in our own solar system, or even in the young planet-forming disks currently surrounding other nearby stars. A separate measurement of deuterium, a heavier form of hydrogen found in the water the comet was releasing, told a similar story, with some analyses putting the enrichment at roughly an order of magnitude greater than what is typically found in comets native to our own solar system. That kind of deuterium enrichment only tends to form in extremely cold environments, colder than about minus 243 degrees Celsius. Combined with the carbon isotope data, it painted a strikingly consistent picture. This object formed somewhere unusually frigid and unusually long ago, in a part of the galaxy that current models associate with what astronomers call the galactic thick disk, an older, more scattered population of stars than the relatively flat disk our own sun belongs to. A region where stars tend to be older, move on more erratic orbits around the galactic center, and carry a chemical history stretching back to a much earlier chapter of the Milky Way's formation. Working through those numbers, Cordner's team concluded the object likely accreted its ice somewhere between 10 and 12 billion years ago, during an early, intensely active period of star formation astronomers sometimes refer to as cosmic noon. For context, our own solar system is only about 4.5 billion years old, and the universe itself is roughly 13.8 billion years old. This comet may have already been drifting silently through interstellar space for longer than our own sun has existed at all. Cordner told reporters at the time that it might genuinely be the oldest object ever directly observed passing through our solar system, a claim that is difficult to overstate the weight of when you actually sit with it. Darrell Seligman, an astronomer at Michigan State University who has studied the comet extensively but was not involved in the nature study, said plainly that before these measurements, getting this kind of detailed chemical and isotopic information from an interstellar object was something scientists could previously only dream about. Now, let's talk honestly about the claims spreading online right now, because they deserve to be addressed directly rather than ignored, and because understanding why they are false is just as important as understanding what actually is true. There's a version of this story circulating across social media and certain corners of the internet suggesting that the joint observations from Webb and Rubin are secretly evidence of an approaching alien spacecraft tied to decades-old predictions from a self-described mystic and supposedly being covered up by unnamed officials ahead of some predicted arrival later this year. None of that reflects anything published, measured, or supported by a single credentialed researcher actually working on this data. There is no classified memo. There is no suppressed thermal signature. There is no coordinated cover-up involving two of the most heavily scrutinized, publicly funded observatories on the planet, staffed by hundreds of scientists across dozens of institutions who publish their raw data openly for anyone in the world to check for themselves, download, and independently reanalyze. What actually happened is far less cinematic and considerably more impressive once you understand it properly. Two extraordinarily capable instruments, built by completely different teams for completely different purposes, happened to observe the same natural object using completely different techniques. And their results lined up with each other in a way that gave scientists unprecedented confidence in what they were looking at. Confidence that comes from independent verification, not from any single team's word being taken on faith. That is not a cover-up. That is exactly what good, cross-validated science is supposed to look like. It is worth saying clearly that not every question about this object has been fully closed, because pretending otherwise would be its own kind of dishonesty, and honest science reporting means acknowledging the parts of a story that are still being worked out, not just the parts that have already been neatly resolved. Earlier in the mission, some researchers noted that 3I Atlas was not developing the kind of long, dramatic tail that sunlight pressure typically pushes off an active comet, which led to some speculation about whether its nucleus might be unusually massive or its surface unusually resistant to that pressure. Additional data obtained by Webb in early August of 2025 allowed researchers to estimate a mass loss rate for the comet of around 150 kilograms per second, with a calculated gas outflow speed of roughly 440 meters per second. When those values were factored into the basic physics of momentum conservation, the lack of any measurable deviation in the comet's trajectory implied the nucleus needed to be extremely massive to resist being pushed noticeably off course by its own outgassing, with an early estimate placing the minimum mass at roughly 33 billion tons, a number that, if accurate, would have made 3I Atlas dramatically heavier than either of the two interstellar visitors that arrived before it. Later, once the comet moved past its closest approach to the Sun, and astronomers could finally separate the glow of the solid nucleus from the surrounding coma using multiple Hubble observations taken across late 2025 and early 2026, that estimate was refined down to an effective diameter of approximately 2.6 kilometers, with an uncertainty of around 400 meters, considerably more precise than the earlier range, though still confirming this was a genuinely large object by interstellar standards, and notably heavier than Borisov, the previous interstellar visitor, even after the more extreme early mass estimates were narrowed down. There's also the matter of a genuinely unresolved chemical puzzle involving metals, and it deserves an honest mention here, because it is the one piece of this story that legitimate scientists themselves have publicly described as puzzling, not manufactured drama, but an actual open question in the peer-reviewed record. In October of 2025, researchers using the European Very Large Telescope in Chile detected a plume of nickel gas in the comet's coma, later corroborated by additional data from the Keck 2 telescope in Hawaii. Nickel vapor on its own is not shocking, having been seen before in a handful of solar system comets, including Borisov. What made this detection different was what was missing alongside it. Every previous detection of nickel vapor from a comet has compared with a comparable signal of iron vapor, because the two metals are forged together inside dying stars and supernova, and typically travel through space bound closely to each other, essentially inseparable cosmic partners wherever else they have been measured. In 3I Atlas, the nickel signal was strong, and the iron signal was almost entirely absent, a result researchers are still working to fully explain, with the leading hypothesis involving a nickel-bearing molecule, something in the general family of nickel carbonyl compounds, that breaks apart more easily under weak sunlight than whatever compound is holding the iron in place at these extreme distances from any star. Both metals typically start out locked inside solid refractory grains, dust particles that normally require intense heat to vaporize directly. Heat this comet was nowhere close to receiving at the distances where the nickel signal first appeared. It is a real anomaly, and it remains genuinely open, with several published papers using words like extremely puzzling to describe it, because nothing in the existing solar system comet record looks quite like it. But an open chemistry question is not evidence of anything artificial. And the same scientific community currently investigating that nickel puzzle also carried out a formal peer-reviewed technosignature search, pointing the Allen Telescope Array, an instrument specifically built to search for potential artificial radio transmissions, directly at 3I Atlas during its passage through the solar system. The result was a clean, complete non-detection. No artificial signal was found at any frequency the array was capable of monitoring at any point during the observation window. So here's where that leaves the full picture. Once you actually walk through everything, both observatories confirmed, rather than the exaggerated version competing for attention online. 3I Atlas is a comet, formed somewhere between 10 and 12 billion years ago, almost certainly around a star that no longer exists in any recognizable form today, carrying an unusually cold, carbon dioxide-rich, methane-hiding, methanol-saturated chemical signature, unlike almost anything measured in our own solar system, first accidentally photographed by the Vera Rubin Observatory before it was even officially discovered, then studied in exhaustive chemical detail by the James Webb Space Telescope over the following year. Every discovery, the carbon dioxide dominance, the buried methane, the methanol enrichment, the ancient carbon and deuterium isotope ratios, and even the still unresolved nickel puzzle, was measured independently by multiple research teams using multiple different instruments spread across observatories in Chile, Hawaii, and space itself. And every single one of those findings has been published openly in peer-reviewed journals, with named scientists willing to explain exactly what was and was not measured, exactly the kind of transparency you would expect from real science and never find in an actual cover-up. That is precisely the opposite of a cover-up. It is one of the most thoroughly documented scientific investigations of a single natural object in recent memory. As for where 3I Atlas actually is right now, it continues its outbound journey away from us, having passed near Jupiter on March 16th of this year at a distance of roughly 54 million kilometers, close enough to Jupiter's gravitational sphere of influence that researchers watched carefully for any trajectory changes, though nothing of dramatic scale was ultimately confirmed. As of this month, the comet sits more than 1 billion kilometers from Earth, moving through the constellation Gemini as seen from our sky and fading with every passing week as the distance between us and it continues to widen. Its brightness on the way out remains somewhat elevated compared to how it looked on approach, a direct result of all the outgassing and dust it shed during its passage near the Sun, and researchers tracking its light curve have found absolutely no evidence of anything resembling artificial self-produced light as it recedes into the dark it came from. NASA and the European Space Agency were both explicit and consistent throughout its entire passage through our solar system, stating clearly that 3I Atlas posed no threat of impact at any stage of its journey, and it never came remotely close enough to Earth for that to be a realistic concern at any point. This is also a good moment to explain exactly why the Vera Rubin Observatory itself matters so much to this entire story, beyond its lucky early images of this particular comet. Rubin only just began full science operations, and it is already reshaping how quickly objects like this one get found in the first place. In its earliest months of operation, the observatory identified more than 11,000 previously unknown asteroids and measured tens of thousands more, a pace of discovery that dwarfs what any single survey telescope has managed before it. And it accomplished that volume of discovery essentially as a side effect of doing exactly what it was designed to do: sweep the same patches of sky again and flag anything that has moved or changed since the previous pass. Its entire design philosophy is built around repeatedly imaging enormous stretches of the sky, night after night, specifically to catch fast-moving, unusual objects like interstellar visitors as early as possible in their approach, while there is still time to redirect other telescopes and potentially even spacecraft toward them before they pass through and disappear for good. Researchers studying the population of interstellar objects increasingly believe visitors like 3I Atlas have been drifting past our sun since the earliest days of the solar system, and that we simply lacked the technology to notice them until the last decade. With Rubin now scanning the sky in this way, some researchers estimate the observatory alone could help identify dozens more interstellar objects over the coming decade, and scientists have already started informally referring to whichever one turns up next as 4I, whenever and wherever it happens to be found, continuing a naming convention that, until just a few years ago, nobody expected to need more than once or twice in an entire human lifetime. So when you strip away the invented mysticism, the fabricated cover-up narrative, and the borrowed language of alien invasion timelines that has nothing whatsoever to do with the actual published research, what remains is still an extraordinary story. Arguably more extraordinary precisely because it does not need any embellishment to hold your attention. Two of the most sophisticated scientific instruments humanity has ever built independently confirmed they were looking at the same ancient traveler, a comet older than our own sun, carrying chemistry locked into ice long before human beings, or possibly even the star it originally orbited, ever existed. That comet was caught in Rubin's camera before astronomers even knew to look for it. Studied in exhaustive detail by Webb over the following months, chemically fingerprinted by ALMA, checked for any hint of an artificial radio signal, and found at every single step to be exactly what the physics predicts a genuinely ancient interstellar comet should look like. Nothing more and nothing less. Because its material formed so long ago, researchers say it is essentially impossible to trace this comet back to its original parent star, since billions of years of orbital drift through the galaxy erase almost any usable trail back to a point of origin. That star may not even exist anymore in any form we would recognize. What we do know, with real confidence, is that 3I Atlas will not be the last visitor of its kind, and that the next time two great observatories confirm they are staring at the exact same distant traveler, it is far more likely to be a triumph of careful, patient, cross-checked science than anything resembling the story currently circulating without a shred of evidence behind it. If you want to know what Rubin and Webb find the moment the next interstellar object gets spotted, subscribe and turn on notifications, because we will be covering the real data the moment it gets published, without letting the loudest, least accurate version of the story get there first. Share this with someone who has already seen the exaggerated version of this story circulating online, because the real one, an object older than our sun, caught by pure chance before it was even officially found, deserves to be the version that actually spreads.